All right, now you have a garden hose. You've got the diameter of the hose. You've got the rate at which it fills a bucket. And 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 so this first part where we're looking for the flow rate and the velocity is just like problem 6. All right, so the first part of this, we're going to do our flow rate is volume over time. Well, we've got the volume and we've got the time, right? So 0.127 cubic meters divided by 1.75 minutes times 60 seconds per minute to get the seconds. And so we've got our flow rate. And just as before, we can calculate Q is AV, and I'm going to go ahead and solve this for V. V is Q over A, is Q over pi R squared. And what's R? R is the diameter that we're given, D over 2, is 2.09 over 2 centimeters times, okay, so we need to convert to meters. Okay, so that's going to be 1.045 centimeters over 100. Oh, I need an equal sign in there, don't I? That's meters, so 0.01045 meters. All right, so we know Q from this equation up top. We know R because we figured out how to get to R, so we calculate the velocity. Now we know the velocity of the water in the hose, but we're asking for the velocity of the water as it comes out of the nozzle. All right, we know the velocity in the hose. What's the nozzle, the water coming out, the velocity coming out of the nozzle? Well, the flow rate has to be the same. So the area of the hose times the velocity of the hose in the hose gives us the flow rate in the hose. And water's not being destroyed or evaporated or anything along the way. It's all coming out. So the flow rate coming out has to be the same. So area of the nozzle over times the velocity of the nozzle. What are we after? We're after the velocity of the water coming out of the nozzle. And so we just solve for that. The velocity coming out of the nozzle is the area of the hose over the area of the nozzle, right? Times the velocity in the hose. Now we know the velocity in the hose. We figured that out up here, right? That's what that's what all these bits are. We know the area of the hose. That's pi r the hose squared. The radius of the nozzle, again, you're given diameter, so you have to divide this by 2 and then by 100 to get to meters, and use pi r squared, the area of a circle, to get to the area of the nozzle. And once you have the area of hose divided by the area of the nozzle times the velocity of the hose, you've got the velocity in the nozzle. And that's it for problem 7.